In today's class, we will discuss uh, LED interfacing. LED interfacing with microcontroller. We take 8051 as a basic microcontroller in embedded system. Okay, we all know LED stands for light emitting diode. Light emitting diode. And therefore the short form abbreviation is LED. Generally, it is denoted by a symbol like this. Okay, it is like a normal diode, but it emits light when it is forward bias. So when this diode is forward bias, it emits light. Okay, and therefore it is called as light emitting diode. Generally, the forward drop potential of this diode is of the order of 2.6 volt, and the current flowing through this will be around 10 to 20 milliamperes. Okay, so we have to design a circuit in such a way that the current flowing through the diode will ensure about 10 to 20 milliamperes, and the drop across diode LED is around 2.6 volt. Now when we want to interface LED with microcontroller, we need a microcontroller, and we know that 8051 family of microcontroller 8051 family of microcontroller have four ports, four general purpose input output ports. They are called as GPIO ports, general purpose input output port. So they are four in number, and they are denoted as port 0, then port 1, port 2, and port 3. Each port can be used as an input port or can be used as an output port. So depending on the configuration of these port bits, we can use these ports as input port or output port. Apart from data input and output operation, these ports are having some other operations as well, and therefore in microcontroller there is a multitasking facility. Multitask facility is available. We'll see this in detail in later sections. Today we'll focus how LED is interfaced with microcontroller 8051. So every port is bit addressable, which means we can access individual bits of every port. All right, that means if we are interested in, let's say, port 2 is a 8-bit port, and therefore we can access all these 8 bits. Suppose this is my port 2 register, which has 8 data bits. Let's say D0, then D1, then D2, D3, then D4, D5, D6, and D7. These are the 8 bits of port 2. So we can access individual bits like port 2.0, similarly port 2.1, port 2.7. We can access individual bits. So this is the important facility available in microcontroller as compared to microprocessors. We can access individual bits. So we make use of this facility. Now you all know this is my microcontroller. I will draw its schematic. This is my microcontroller. Okay, and let's say this is port 2.0 pin. Okay, I am going to interface LED. with port P2.0 pin. Okay, port P2.0 pin. I can connect this LED to any pin, but for example I have used this. Interfacing means connecting interfacing means connecting a device to microcontroller to microcontroller. This is what the meaning of interfacing. Okay, so we are interfacing LED means we are connecting LED to this port pin P2.0. so here we connect with the help of wire, and this is my LED. You all know symbol is like this. So I am connecting LED like this and connect other end of this pin to the ground. Now microcontroller works on 5-volt power supply. 5-volt power supply. Okay, so it has a capacity to supply voltage up to 5 volts, and it can supply the current up to few milliamperes, and therefore there will not be a necessity of resistor. There will not be a necessity of current limiting resistor. Okay, but we can connect these resistors practically when we build a circuit. Okay, so current limiting resistors are important part when we connect an LED. All right, so this is my interfacing diagram. I have connected LED to pin P2.0. Now while writing the code, initially I have to use the command sbit. Sbit command is used to assign individual bits of ports or port pins. Okay, so for that purpose sbit command is used. So we can write command like this: sbit P2.0. okay, so this is a way, this is a cap symbol, and this is used to assign sbit P2.0. okay, so we are assigning P2.0 to this as an LED. Okay, so we write here this variable as LED. Okay, so we write command sbit LED is equal to P2.0. so wherever P2.0 we have to write, it can be replaced by LED. Okay, so this is a way we can make use of port pins. All right, then in Keil we are going to use a Keil software for writing a program. We are using Keil software, which is called as a cross-C compiler, and along with this we are going to use a Proteus software. Proteus software is a simulation software used for simulating any kind of circuits. We can simulate any kind of circuit. Any kind of circuit can be simulated using this Proteus software. Okay, so we are going to use these two softwares to physically observe how this particular circuit works and how it runs. So let us quickly go to the demo. So this is my Proteus software. Here you observe I have connected pin P2.0 to the LED. I can pick up these devices from this device library, which is available in Proteus itself. So I can pick LED like this. You just simply type LED, then select up to electronic devices, and then you can select any kind of LED which you want. Okay, so I have selected red LED, and I have used here microcontroller, basic microcontroller 89C51 here I am using. So this is my schematic. With the help of this schematic diagram, I am going to run actual program on this. So physically when we build a circuit, we need a programmer, we need associated circuitry, we need a power supply, and so many other things we require. But here in Proteus software, with the help of this simulation tool, it is very easy for us to simulate any kind of circuit. So here we are testing how these microcontroller circuits are tested. Now let us quickly go to the Keil environment. This is my Keil software. In the next video, I will demonstrate you how these programs are written and how to build a project. But this is a sample example to demonstrate how it is run and how it is executed in Keil. So that's why I just demonstrating. So here on the left hand side there is a project window, and on the right hand side there is a editor window in which we can write the program. So ledblink.c is my C file which I have written for LED blinking, and you observe this file I have included here in this project. Okay, the title of my project is LED blink. Okay, now you just understand the programming logic. Here I need to use this include rec51.h file. This file is very essential because all the registers, all the input output functions which are necessary for performing various operations in Phi1 are included in this editor. So that's why this include statement is very important, and it is similar to the include stdio.h that we normally include in C environment. So it is as good as we are including library of Phi1 microcontroller. This is sbit command which I have explained already to you. Sbit command is used to define the individual ports of the microcontroller. So here I have used a variable LED which will be assigned to port pin 2, 0 or 2.0. This is my main program. Here what I have done, I have assigned an integer variable delay which I have initialized to 0, and I have written one simple for loop because I want to run this LED blinking infinite times. So that's why while true condition is there, I have to execute when true, I have to execute this statement infinite number of times. So this loop will execute infinite number of times. So in void main I have written this. So LED is equal to 1, which means P2.0 I am making 1. When I am making this pin 1, you understand when any pin is made 1, it means it is high. There is a logic high. And when that pin is made 0, that means there is no voltage or there is low voltage on that line. So here you observe LED is equal to 1, which means on this port P2.0 output voltage is high. Then I am calling a delay. This delay I have randomly generated for few milliseconds, okay, in order to display that LED on for some time. Okay, so that is why I have called this delay function. Then again I am making that LED 0 because initially LED was high or on. Now I am making it off, and again I am calling delay, and this process is continuously running. Okay, so when this program is completed, you just build this program. After compile this program. After compiling, you will observe there are 0 errors, 0 warning. Then you compile and build. After compilation, you will observe that hex file is created. So I have already made a folder here in which I have saved these all files. So here LED blink is my folder, and in this LED blink is my main project, and this hex file I have generated already. So I will go back to the Proteus, and now I will flash this hex file into the microcontroller. Physically, when we go for flashing hex file into the microcontroller, we need a programmer, but here we just need to provide a path of that hex file. So you find this hex file will be here. So I will just open this file. Okay, click OK, and simply now run the simulation. You will observe that the LED will blinking. Let me zoom it little bit so that you will understand and you will see it properly. Now you see for some time LED is on and for some time it is off. See, it is clearly visualizing. Okay. All right. Thank you guys. So in the next videos, I will demonstrate few more interesting interfacings such as LCD interfacing. Then I will display switch interfacing, DC motor interfacing, stepper motor interfacing, and so on. So keep watching these videos. Thank you very much.